We're going to talk about HTTP caching, and the reason I wanted to do a talk on HTTP caching was because first, no one talks about it really, and that's useful as a speaker because it gets you in conferences like here, and also because everybody gets it absolutely wrong. It's the one part of HTTP that most people misunderstand and do completely the wrong way around. And when I say people, you can introduce your own name, your company name, or Microsoft. It all works the same way. So we're going to start from the very beginning. When you're a young developer, you start on the internet. You can see that's the internet here, with plenty of great computers and then horrible Windows machines. And that's the internet as we know it when we start development. There is no caching involved anywhere. We don't know about cache, and theoretically everything should be fine, and we don't have to think about it. We write our HTML page and JavaScript files, and we start putting them on the server for the first time, get very excited. My Justin Bieber website is online, it's great. And then things start breaking down very quickly because of caching, and you start trying to disable caching as quickly as you can because not the right data is coming back, and you copy and paste code you found on the internet to disable caching, and you copy and paste that in your pages because you have no understanding of how caching works, so you try to disable it, and you usually don't revisit that knowledge, ever. However, the internet indeed has those browser cache components that we can see in red in there, which are there to aggregate content locally so that we can load our most important websites faster in the morning, such as Facebook and lolcats and Wikipedia and others that we do in private mode. So that's great. However, it's not the only level of caching, of course. We've got many other kind of caches. Inside the firewall, we have another type of cache, of course. Not that one, because that was a bad one. That was a very bad one. That's better. We have proxies, and I say proxies plural because there are many proxies. Big companies have very big infrastructures for their proxies. They've got hundreds of thousands of dollars invested in massively scaled infrastructures just to prevent you from accessing that blog entry you wanted to check on Twitter this morning saying it's adult content. True. WebSense, anyone? Anyone got WebSense at work? You know, those big messages? Only one? Wow, you're a very liberal country. In Britain, we love democracy and free speech so much that everything gets restricted very quickly. So we have all these infrastructures, and I'll discuss a little bit. Actually, I'll just discuss it now. I don't really have a schedule anyway. Who cares about the slides? It's interesting. Further, yeah. It's interesting because how many of you work for companies that have multiple sites, multiple areas in which they are, say Europe and America and whatever? Right. How many of you have deployed your own sort of caching infrastructure across all those locations? Anyone? One, two, couple. Right. When you do that, you're basically replicating what's already been done with all the proxies. So we'll see as we go through the caching. If you use caching, you can use the same cache that you use for your browser, for your data. That works great, and it saves you millions. And then your boss will love you, and you'll make plenty of money. Oh no, that bit never works, does it? So we've got proxies, and we've got plenty of them, and they're chained, and it's all very complicated. And it's infrastructure that we don't know about, because it's not maintained by developers, usually. It's maintained, network admins, I think. I think they put all of them in a big bunker on at the base of the building, because you never see them, you can't contact them, and they try to protect themselves from you as much as possible. I assume there was a war a couple of 100 years ago between network admins and developers, and they all went fighting, and one of them won, and the other ones are in the basement. That's the only thing I can understand. But, you know, those guys are maintaining all those proxies, so they're there. Now, proxies are not the only caches that exist in the infrastructure. We have reverse proxies. Reverse proxies, it's just a couple of examples of proxies. The big GUI thing over there, for those of you that don't eat much fish is a squid. It is a squid. And squid is the name of a reverse proxy. So what's a reverse proxy? It's a machine that you put in front of your server that's going to get the first internet request to your server, go to your server, cache it, and then send it back. And then any further requests that come in, your reverse proxy is going to answer instead of your server. So it's a way to dynamically expand the amount of caching that is done on your side and reduce the load on your servers. One of them being squids. There are others available. They're usually very cheap, and they are very useful to do outscaling very quickly on very large websites. Plenty of presentations online on reverse proxies. I recommend particularly the ones on the caching infrastructure at Yahoo. For Yahoo used to have a lot of traffic, apparently. But it's a great infrastructure anyway. And we even have translating proxies. This is a Babel fish. Anyone Hitchhiker's Guide to the Galaxy? Yeah. So that's the little fish you put in the ear to be able to understand various foreign languages, such as speaking Mark Rendell. That works well for me anyway. It's a terrible picture. If you find a better picture of a Babel fish, please send it to me. So the translating proxy is there to translate between an original content type and the content type that is expected by your browser. So that lets us, for example, dynamically convert SVG to Canvas or XHTML to HTML. And more importantly, how many of you think you've used the translating proxies before? Right. How many of you use a mobile phone to connect to the internet? Right. So all of you are using translating proxies. And you don't even know about it. When you connect, what is it called? When you connect your computer to a phone to access the internet? Tethering. There you go. If you use tethering, most network operators are running massive babies like this on their network to take all the JavaScript files and the CSS and compress it and deliver it in a completely different format to your computer, which makes for a very interesting support request from your client. So that stuff is running in the wild continuously. You probably used it before and you never saw it. And if one day you think you're becoming schizophrenic because the view source on the web page of your client doesn't look anything like what you just built, just check that you're not using tethering instead of your local network, especially if you're in the States, because that's going to cost you a fortune. But if you see different content, you may be going through a translating proxy. So we've got all this proxying infrastructure everywhere, plenty of different caches that have plenty of data accumulated in various parts of the system. And of course, as you know, there's only two difficult problems in IT: naming things, cache invalidation, and errors off by one. That usually works much better, that joke. I'll rethink it. But thank you very much anyway for the effort at the front. Cache invalidation is complicated. The way we scale the internet is by not doing cache invalidation dynamically. If I update my page, I don't let the whole internet know about it. I can try, but no one really cares about my Justin Bieber page that much. So the caches are not going to be able to know that your page has changed. So we get a lot of data that gets in various states of invalidity over time. And we're going to have a very quick refresher course on how all this stuff works. So by default, out of the box, you post your Justin Bieber page and a link to Amazon to buy big golden shoes. And do I know too much information about this? Probably do. And you put it online. So how many? What do we do by default? Are caches and proxies and browsers, are they allowed to cache by default, or are they allowed? Or should they not cache by default? Who thinks you cache by default? Who thinks you don't cache by default? Who doesn't think or has no arms? Okay, right. Well, by default, of course, everything can be cached. Everything can be cached at any point in time. That's what HTTP says. Interestingly enough, that means that the amount of time things are going to be cached for is going to be left up to the proxy. There's no direct instruction you can give saying cache for X amount of time. The proxy is just going to decide how long it's going to cache the data. How is it going to do that? It's going to do that using heuristics. Now, if you type heuristics in Google, you can get your phones out and check, because I'm not actually joking when I'm showing that slide. If you type heuristics in Google, you'll see that you've got unexpected results sometimes, right? This is a screen capture from me typing in Google during a conference. So if you want to type it on your phone, do it. If you want to complain about the fact that there's only a lady and not a guy, I agree with you. So please get more guys referenced for the keyword heuristics when they wear their underwear. I have no idea. So we end up with unexpected results. We probably don't want to have that many unexpected results when we want to cache our content. So one of the things we can start giving is the last modified of our document. Last modified is going to let us start doing a first kind of optimization using conditional requests. So this is what an HTTP request looks like. Anyone has never seen an HTTP request? What do you guys do for a living? Okay, this is an HTTP request. I don't have a little fancy pointer, but the first line has a get, which is called a method, not a verb, which indicates what you want to do with the URL that is just behind it. So here I want to get my presentation. I'm sure you get it. It's to download the content, of course. And then you've got, just underneath that, the results from the server, 200 OK. Really, a server that serves my presentation should say 200 awesome. Which you can do, by the way, if you have a lot of time on your hands. The 200 is a status code that indicates exactly what happened. In the range of 200, something went well. And underneath that, we have a bunch of HTTP headers, which are key value pairs. And here we've got the last modified. Now, last modified is the thing that people start adding the most. And I want you to look at this line very carefully, especially the end of it. Because this is a format called an HTTP date. And in HTTP date, the only value that you can put at the end is GMT. The older something is, the most unlikely it is to change, which means that if a document is 10 years old, I can probably cache it for a year, because it's unlikely to change. If it's 10 days old, I probably want to cache it for a day. And that's what the HTTP specification says. Once we've cached it, we can start doing a conditional request. So here's your HTTP specification with a new status code. For those of you that are not web developers, we'll have more microphone problems. I can remove that one. Okay, I can remove that one. Fine. Wonderful. We have a status code, a different status code, which is not 200, which is exciting. We're discovering something new. In the request here, you can see the first line underneath. It's called if modified since. This is a conditional request. It tells the server, please give me the content only if it hasn't changed since that date. The server at that point returns a 304 not modified, which says, you're cool, you've got the latest version, I don't need to retransfer the whole request. So we've got one level of optimization here, which is I do not transfer the data again if I don't need to. But we want to be a little bit more explicit when we want to start caching things and provide a more specific expiration. As we know, it may come in quite handy sometimes. So we're going to do an expiration of 60 seconds before a message self-destructs. This is what it looks like. A new HTTP header. Isn't that exciting how much HTTP you're learning today? Expires header, same thing as an HTTP date, no GMT +1 in there, please. But we give an absolute time at which the content can expire. Someone tell me a problem right now with this code, right now. Just think about it very carefully. Anyone can point a problem if I just use this? No one? It could be, yes, that would be another problem. Yes. It could be that the expire is after the last modifier. We'll see later. That's a scenario that's actually already covered by HTTP. So that will work. Now, there's another problem. Now, yes, the clock could be wrong. Our computers very rarely come with atomic clocks because they're not very portable, I hear. So we tend to rely on 2 or 3 in the world that end up giving you time. It's actually quite worrying that 80% of the computers in the world are taking their time from Microsoft. They have a huge amount of power to draw us back in the past. If they ever wanted to do that, which I'm sure they won't. So yeah, the clock could be wrong. If the clock is wrong, of course your expire header doesn't mean anything because it's in the time reference of the server and not of the time reference of the client. As we all know, time is only relative when you change the point of observation. So yeah, just pretend you know what I'm talking about. I do it all the time and it works great. So we've got another way to describe this that doesn't involve absolute times, it involves relative times, and this is the cache control directive. Yeah, I'll go back to that, I don't care. That's a cache control directive, yet another HTTP header, new to HTTP 1.1. So if you don't know that one, it's very fresh, very new, it dates back from 95. Don't hesitate, use it as much as you want. It works for all new clients out there. The max age is 60 seconds. It's relative. It lets us provide relative times. I don't have to go through the whole problem of clocks. If I do I have a conditional request on that one? Yeah, okay. Yeah, okay. So, what is that? Yeah, okay. So, I'm going back to that slide. I'll just move the slide afterwards. I keep on modifying those slides, you know, they grow over time and I sometimes forget what is what. So we've put 60 seconds in the cache control. We're going to cache for 60 seconds. That means that if a proxy is going to cache this information, we're going to have a response that looks a little bit like this. And you can see that yet another HTTP header is being introduced, the H header. This is stuff that exists in the wild, even for the most experienced web developers. It is not something that we usually look at. It's one of those HTTP headers that may be there and we never actually realize it's there and we completely blank it. Poor little HTTP header, always being blanked. But it's very useful because it tells you how long ago was that data cached. Here, I know that the document was cached 59 seconds ago. So check that if you want to know if things are served from your cache when you're in your company and you're running Fiddler and something looks a little bit fishy. Fiddly, even. Christ, I'm on fire today. Hello, welcome, join in. Yeah, you can check the H header and you will know immediately if the proxy has indeed returned a cached entry or not. So, interesting fact, you can make the expiration time different between the browser and the proxy. That's just a trivia question in case you go to a pub quiz. We love pub quiz in Britain. And the pub quiz happens to be on HTTP caching, which I'm sure most of the pubs around the country in Poland do all the time. You can specify multiple cache control entries, one for the shared proxies and one for your local cache. Very useful if you want the browser to not cache, or the browser to cache this stuff, but not the proxies, for example. Again, because restarting the browser from a user perspective is easy because we talk to the user. Restarting the proxy, as we said, the bunker in the basement, much harder. So we tend not to do it. So, just a side note, because I like very bad jokes. I'm the champion of that. Time is relative. This is how you fix the time relativity problem, by the way, right? So. That doesn't involve string theory, that is. That's a physicist joke. I know it gets worse, trust me. So the expire header, as we said, it's an absolute point in time. Now we need to make it back relative. This is for HTTP 1.0 client. We can do it by the date header. Yet another header. Great, exciting. The date header is just the time at which the server processed the request. At that point I have 2 days, I can subtract them and I go back to having a relative amount of time. Wonderful. All this means that data can be served cached for a while, and cache means that the data may be outdated or not very fresh anymore. And the freshness model in HTTP will explain why you probably will get it wrong a couple of times. What do I talk about when I say freshness model? Whenever you've got a resource on the internet, anything that has a URL, it can live through its life in different states. The original state is the cute state, is the fresh state. Everything is new and fabulous, and you are virginal, washed of all sins, etc., etc. Depending on your religion, of course. But cute baby anyway. Once you've been fresh for a while, once you've been born, the next time around, the data can be served from caches, from proxies. At that point, we call the data fresh. It's not from the origin server being the server that originally created the page, your Justin Bieber server. That one is going to follow us to the end, so just get used to it. But it's when you've requested it in your browser, it doesn't come from the original server. The resource is called fresh. Now, if you leave bread in that kind of environment for a while and it gets a little bit warmer, you just end up with very stale content. And stale content means the content has expired. That's the expiration time we gave earlier. So first request, I'm new. For 60 seconds, I get cached, I'm fresh. Over 60 seconds, I'm stale. What do we do with stale data? Get rid of it? Yeah, you could change those stale data in the servers. Yeah, you could. Should a proxy give you stale content? No? Who thinks no? Who thinks yes? Who just wants lunch and doesn't have the courage to just leave the room? Yes, it can provide you stale content, of course. First, there's nothing that prevents any server from giving you anything it wants. Because there's not a policeman next to each server going, oh, right. So, yes. And secondly, yes, sometimes the server is going to give you outdated data because it's easier than not to give you data at all. If you work with the most polite people in our whole industry, traders, that's a joke for people working with traders. They have about the patience and the attention span of a squirrel. And they really want their data, so it's better to give them something that's outdated than not give them anything. I mean, if you want to live a little bit longer, that is. So, I didn't do front desk. Apparently, I have a behavioral incompatibilities. So there you go. So stale content, yes, can be served by a server. As you'll see, yet another HTTP header. My God, your heads are going to explode with all of them. Don't worry, you've got white t-shirts. I can write your favorite HTTP header on your t-shirt when you leave the room. I know, how exciting. So, we've got a warning header. The warning header is looking a little bit like a status code. It's got a number and then a description. The number is telling you exactly what happened and why. So if you end up with stale content, it is required for the proxy servers to write that information. Again, if you're looking in Fiddler and you don't understand what the hell is going on, you should have it in your request, unless of course you're using Microsoft ISA server, then things are a bit more well, anyway, they're just non. It's great. It's a great product, by the way. It's just, it is. It's I'm not joking. It's actually a good product from the HTTP point of view. Right. So the server can give us stale data or fresh data or not give us any data at all, and we want to have a little bit more control because we like control. You know, you like control of your own data. So I'm going to give you a couple of instructions that are going to... Yeah, okay. Yes, a couple of instructions that are going to be useful that you put in your caching instructions. You know the cache instruction header that we saw earlier with the max age, etc. We can add more data to that. And there's a couple that are interesting that I'm going to explain to you now. And they're confusing because the HTTP specification is actually very confusing. It names things the wrong way around, or people were drunk when they wrote it. I'm not sure which one it is, but what is sure is that it's very confusing. So, no store doesn't mean do not store. That's not what it says. It says do not put it on a hard drive. It doesn't say anything about keeping it in memory. It just say, because if you can't keep it in memory, it's going to be bloody hard to transfer over the internet. But it doesn't mean do not store on any media. So if you have a flash drive, technically should be allowed. It just says try to not keep it around for too long. Now people see that, get very excited, and say, going to use that, and then no one will ever store the data, the sensitive data I send. Well, if you've sent it already, there's nothing, again, that prevents the server from taking all your data, dumping it on the hard drive, and adding a header saying, fuck you. So, I wouldn't rely on the no store to do that, really, unless you own your infrastructure. So, the reason for that kind of headers is to be able to communicate your intent on not keeping stuff on the hard drive. Now, if you have a reverse proxy, like we saw at the beginning, Squid, you control your server and the reverse proxy. You can have the policeman next to the server saying, do not store that on the hard drive, because you can fire the guy that writes the code. So that gives you the control you need, and this is giving the visibility that you can use to communicate your intent to the proxy. Now, we get to the ones that are the most misunderstood. Must revalidate doesn't mean that it must revalidate always. It just means it must revalidate sometimes. Which, of course, must and sometime, I don't know. Can revalidate, should revalidate, please revalidate, I'm not sure. Would have been much better than must revalidate, but there you go. That's another HTTP caching instructions, and we'll see. This means only revalidate. So when, rewind, replay. What do I mean when I say revalidate? It means that the proxy would have to go back to your Justin Bieber page to re-download the resource because of whatever reason. That's revalidation. I'll go back to the server and then ask again for the same data, compare it with the one I have. When I use must revalidate, it means that the data will be revalidated only when it's stale, after it's expired. Before it's expired, no one needs to go back to your server. And that's very confusing for a lot of people. They see, for example, Silverlight is caching stuff very aggressively. It still respects the HTTP specification, but it's confusing, because you said you must revalidate with me. Yeah, but the data is actually cacheable, cached, and not expired. There's no reason for Silverlight to go back and ask for your data. Perfectly valid HTTP, but confusing. Of course, no cache does not mean do not cache, because that would be way too simple. Actually, it's even more complicated than that, because it depends on which version of HTTP you're looking at. So we've got pragma no cache, which you've all probably copied and pasted once in your life in an HTML page. That's HTTP 1.0 way of saying do not cache, and that does mean do not cache. In HTTP 1.1 it's much harder. No cache means only revalidate with the server. It doesn't mean do not cache the data on your proxy. It does not mean do not store the data. It does not mean do not reply to conditional requests. It does not mean any of these things. The only thing it means is check with the server if something is new. So I'm going to show you a diagram that's going to clarify everything as best I could do with PowerPoint. One day Microsoft will actually release a presentation piece of software that doesn't generate horrible diagrams, but they've only been at it 15 years, so in 2040 I expect to have great presentation slides or continue using my Mac. So we have the up-to-date resource. That's the first time it arrives. Then we have a resource that is fresh. You cache it for 60 seconds. During 60 seconds it is fresh. That means that if you put the must revalidate, nothing will happen. The proxy will cache it and serve it, and you will never know about it, which makes for very interesting statistic generations on your server, because you don't see any request. However, if you specify no cache, during those 60 seconds, a conditional request will be made.
So that means even if you put no cache, the proxy, while your data is fresh, is going to put it on the hard drive and it's going to be served. Except your server is going to get one of those conditional requests we saw earlier with the if modified since, and the server will probably reply with 3 or 4. Okay? So, no cache doesn't mean no cache. Must revalidate doesn't mean you must revalidate. So, how do you manage to disable the cache? That's, again, a trivia point. We need to do a couple of things, of course. We need to specify that the data is already expired, which I do with max age 0. And I want to say no cache, because I want to say that the data should always come back, the request should always come back to the server. And no store, I just put it in there because it was there, so I thought, why not? There's a little bit of butter at the end of the jam, and you just want to spread whatever you have. Now, that's great for HTTP 1.1. As I said before, HTTP 1.1 is from 95, I think, something like that. Before that, we had HTTP 1.0 that worked differently, and even HTTP 0.9 for those of old timers that remember that specification. And when I say specification, I mean email. We need for HTTP 1.0 to use the old expiration systems. So with the date and the expire. The date is usually generated for you by most of your web frameworks out there, so you don't have to add it yourself. But the expiry needs to happen. If you put expires -1, it's an invalid date, right? It's not a valid value. I know that a lot of people tend to do that, but it makes people like me that read the specifications all the time a little bit itchy. So if you don't do it, then I'll be happier. If I'm happier, you'll probably survive another day. No, please use dates. Please use dates in the past. So here it's a date in the... That's actually completely wrong that it's expired. Yeah, isn't it? 1st of January 2000. Oh no, it's an expiration in the past. Yes. Sorry, as you probably can tell, I enjoyed the bars and pubs of Kraków quite a lot last night. So, I'm not as energetic as I normally am. Okay, the expires header is in the past, which means that the data is already expired. And of course, just because we can, we'll just add pragma no cache. At that point, maybe you have a probability of a chance to be asking your proxy to please try not to keep stuff around too long. Maybe. But again, nothing forces anyone to cache stuff. Right, so we got last modified as a way to provide expiration. We've got a max age, which is another way to provide expiration of content. There is a third way. That lets you... What time is it? Yeah, that's fine. There is a third way that lets you provide sort of a kind of a version. It's called ETags. How many of you have implemented any form of ETag support before? There, yeah. So, there are 2. We've got 3 people in the room. There's a good reason for that. They're horribly complicated to get right. And they're horribly badly documented as well. Or rather, they're just documented wrong. Okay, people say... Apparently, people say stupid things on the internet. Argument followed, everybody is fine. So, ETags are a way to provide a sort of version identifier of a document. Version 1, version 2, version 3. So just a string, okay? And it's used for conditional requests. It's used for conditional request instead of if modified since, which is the header we saw earlier. Why would you think that we would need that instead of an if modified since? Any ideas? Because of the clock, yes, you are correct. More specifically, why? Give me that phone. I'll answer. Clock resolution. Well, there's clock resolution. HTTP dates, I told you before, it's a very restrictive format. It goes to the second. What happens if things change more than once a second? Now, if big financial services, they will change, you hope, more than once a second, because you want as much traffic as you can. So, when you try to replay, for example, messages, you probably don't want to use the current position in a feed based on the dates, because you're going to lose messages. If you lose messages, you're going to not stay in this job very long. Well, you would think, but you'd be surprised. The memories. I worked in banks, that's why. So, yes. So we use ETags because they are a much more reliable way of knowing if something has changed. And ETags come in two shapes. Again, I'm very sorry for my slide clip arts. They come in strong and weak format. I'm not going to bore you with the details. Just know that they exist in two different kinds. And based on the kind of ETag you provide for your document, you're not going to have the same guarantees. So, strong ETag means that whenever I request something, any change will make a change to the ETag. Anything. So, if my customer details or change because his address changed or because he grew a mole on his bum, it will change the binary form. It's a binary level thing, right? The document that you send back, the bits that you put into the HTTP body or the response stream is going to change. It has to change. If it has the same ETag, it means that byte for byte it's the same one. Weak ETags, it's a bit relaxed. So yeah, well, we may change the bytes a little bit, but you won't mind, would you? It's just a bit of cleanup. So you can do plenty of things with strong ETags, such as partial downloads called range requests. When you download, or back in the days, we used to have those big download managers downloading multiple segments of a file at the same time to go quicker. Anyone that's still downloading porn of the internet will know that it still exists, or it did until, what's the name of that website that came down? Rapid Share, is it? Ah, that was good, that was. Right. So, thankfully, news groups still have wonderful content on them. Wonderful technology, that one. Anyway, completely irrelevant. We use ETags for that. Of course, if you're going to do 20 requests with 20 chunks of data and the binary bytes change underneath you, you're not going to be able to watch that pirated version of the latest Justin Bieber concert. Of course you won't be. So, we need to have strong ETags for things like conditional range requests. And weak ETags, they exist. Now, if you generate your own ETags, chances are you think you're doing it strong, but you're actually doing them weak. Because there's a whole bunch of stuff that needs to happen for ETags to be strong. I'm not going to bore you to the details. Again, just know, well, actually we'll have a slide for that, so I will bore you with the details. This is what it looks like. An ETag is just a string with quotes, and you do put the quotes in. If you don't put the quotes in, it's not an ETag, it's something else that looks and smells like an ETag, but doesn't quack like a duck. So, string and quotes, of course, that's the first request. I got my ETag. Second request, I do conditional. You can see that the if modified since has been replied by if non-match. I reply again with 304 if the data is cacheable. And with the new ETag, of course. Until what time do I have, by the way? Where is everyone? 15 minutes, perfect. I'll even manage to leave you a little bit early. Which means I'm going for food and looking you in. So, to generate strong ETags, the title of the slide is wrong. This is to generate strong ETags. These things need to be done. They're per representation. How many of you use content negotiation on HTTP? How many of you use modern web frameworks? That means not MVC or web forms. Web API, anyone? Simple Web, Nancy, OpenRaster, Fubu. Anyone? Really? Christ. Right, there's a world out there, guys. Alright, so a lot of those frameworks are implementing or out of the box, like OpenRaster and Simple.web, and the other ones are trying to replicate what OpenRaster did 5 years ago and implement it now in their frameworks, which is great. Content negotiation means from the same URL I can serve JSON and XML. This is the simplified version. It's not accurate. A REST purist would shoot me in the head. Thankfully, I probably don't think there is any in this room, because I know all the 5 of them. So, so per representation, you need to have a different ETag for your XML and your JSON because they're not the same bytes. Remember what I told you about byte for byte equality on an ETag. So if you generate an ETag and you give the same for XML and JSON, you're doing it wrong. It needs to always change when the representation changes. That does mean even if you send back an object graph coming from an Hibernate, which is what an ORM looks like if you do it right, as opposed to the entity framework, for those of you that may be using that. Spike, spike, spike. I'm good at that. If you send an object graph and your customer hasn't changed but the orders have changed and you don't update the ETag, you're doing it wrong again. It's not a strong ETag, so you want to make sure of that. And it needs to be unique for the lifetime of the resource. So if you just use version numbers, it's easy. If you use something else, it can become very complicated. You can't repeat the same value twice, right? So do not use an MD5 hash, for example. Why? Because I make a change, I revert the change, it's still a new change, still a new document, but suddenly I fucked up versioning. Which gives us to tips and tricks, and that's the more light-hearted part of the talk, because it all became very serious. And I'm not very good with being very serious very long. Tips and tricks, things you should and shouldn't do. Query strings, don't do them if you want to hit the cache. Why? Browsers, modern browsers tend to respect caching instructions with query strings, but the whole world is using outdated browsers like Internet Explorer 6 or 7 or 8 or 9. And from the HTTP caching perspective, I don't say that in the open very often, but until Internet Explorer 10, Microsoft fucked it up real bad. And I do mean it. The caching implementation in Internet Explorer is atrocious before version 10. They fixed it in version 10. It finally works. It took them 10 versions. 10 versions. I think they wrote 7. Anyone remembers Internet Explorer 2? There you go. I do. I still have the CD at home. Right, so query strings, if you put a query string in a URL, it's not going to get cached by Internet Explorer for a long time. ISA server, the proxies, are not going to cache them. Squid used to not cache them. So if there's query strings, try to avoid query strings if you want data to be cached. How do I solve that problem? If I want to generate URLs based on the query, you use the post redirect get PRG pattern, and you can take your Wikipedia and go and check how it's done. That's one way of generating URLs on the server. Okay, little trick. How many of you build Windows applications? Like proper WinForms, rich, fat clients? Okay, so, as I said before, try to reuse the infrastructure that's already been paid for. I'll give you an example in a financial service company that I cannot name for legal reasons. We had the need to show a lot of data, lots and lots of data. And people started rebuilding their cache, cost a lot of money. So what we did instead is replace that with an HTML page. Very high tech. And the front-end client was just downloading the HTML page and putting it into a list box. Right? Amount of engineering time, about a day. But it worked really well. However, of course, every time they wanted autocomplete, so every time something changed, you have to go to the server, retrieve the HTML, and that was very slow. So, especially as traders, traders' attention span is short, but what they do during the day is very repetitive. They do the same stuff over and over again, which means that the stuff they're going to type in that text box is going to be the same over and over again. Just like Google has 99% of its traffic coming from Justin Bieber's requests, right? So you want to aggressively cache those happy paths. And what we did is to apply the display then request. So you have a wonderful instruction that you can use saying, please provide me the data only if it's already in the cache. So let me explain to you how the software worked. The software queries the browser cache saying, please give me the list of data I need to show if and only if it is in the cache. At that point, if it's in the cache, I display it in the list box. Trader starts typing, trader is happy. In the meantime, I do a conditional request back to the server saying, hey, is there anything new? If the server says 3 or 4, everything's cool, the trader is happy using outdated data, he never saw anything. If the data has been updated, I retrieve it and I display a little message at the bottom of the list box saying the data is stale, please click here to refresh. We managed to have a very, very quick way to display the data, sub-second. Because the browser is already caching this stuff. You can do that on .NET today, by the way, not like this, because that would be too easy. That's the standard way. On .NET, there's a different way. I'll show you a link where you can learn what the proper way is for .NET. But it works. And it works with great, complicated technologies of HTML and list boxes. And of course all this data was cached aggressively across North America, Australia and Europe thanks to the proxies. So very, very low-tech solution. Yes? If you cache already and the data is cacheable and you told the proxies to cache, you won't even need the 3 or 4, right? But the client, the fast client would do a conditional request if it's got the data already. The first time you do it like this, you're going to get the version that's in the cache. That gives you the ETag or the last modified. That means that what you do in the background, yes, you combine it with a conditional. Okay, another one. Hash version in the URI. This is borderline just general web design. We probably want to cache everything all the time because caching is cool. So, to do that, we need to make sure that we don't do conditional requests on things that are going to theoretically not change, like CSS and JavaScript files. How do you do that? You bundle all your files with a version or a hash or whatever you want to put in it whenever you do a deployment, and you tell the system to please cache it forever. That way, each of your CSS and JavaScript files are going to be cached forever for the lifetime of version 1.1. If someone is in the middle of using the file, he can continue using the file. The next version will be a different URL, as such a different resource, and as such could be cached indefinitely as well. So when you do your minifying, bundling and all this crazy stuff, do remember to put some sort of version or hash in the URL. But please don't do it as a query string, otherwise it nullifies the whole point of caching anything. Okay, use CDNs. I'm very, very, very strong-minded on this one. Please stop shipping me jQuery all the time. Seriously, it's fine. It's all over the world already. Facebook already has it. Chances are, when your boss arrives in the morning, he already has downloaded the majority of scripts you need because Facebook used them. All right. So you want to reach cache hits, right? Good programming principles. You want cache hits. You don't want a cache miss. A cache miss is always expensive, be it that it's in memory on your computer or if it's online. So we want to hit the cache. Please minify and bundle whatever you want. Bundling, by the way, should have said minifying is removing the white space in your code, in your JavaScript code, more or less, and bundling is putting all the files in one big one. Long discussion that we're not going to get into. But if you do the bundling, please don't bundle stuff over and over again that's already there. And please don't give blanket statements such as, you should always bundle everything in one page. Because that's a little bit silly too. There's plenty of grey. Try to bundle what you can, but make sure that the things that can be cached for longer and are going to change less are independent. Because I'm really also tired to re-downloading 1.5 meg worth of JavaScript every single time someone decides to do a new deployment, which you should be doing 25 times a day. Or an hour, or a minute if you're GitHub. It's true. They deploy 1,000 times a day, I think. The GitHub website is deployed 1,000 times a day. That's continuous deployment for you. So, know when to minimize and bundle. I'm going to ignore that one. No, I'm not going to ignore that one. We've got about 5 minutes, and I leave you a couple of minutes early. When we use the translating proxies with our mobile devices, a lot of our content is already being changed. Do not implement minifying and bundling blindly thinking it's going to help with mobile, because chances are mobile is already addressed by your mobile operator. However, if you do minimize and bundle and you decide to get people to be cached and you do crazy things like XHTML, how many of you have websites with XHTML in them? 0. Yep, that's about the same amount as on the internet. So sad, because I love that technology. Cache control, no transform, gives you a way to tell the translating proxy, the little Babelfish we saw earlier, to not mess with your content. All right, it's the Robert De Niro of caching instructions. Fuck my wife. Anyway, was that Danny DeVito? I'm not sure. That doesn't matter. It doesn't matter. They all look like gangsters to me. So, caching on SSL. Now, hopefully most of you run your websites using some sort of SSL or TLS or some sort of secure HTTP. If you do that, the common knowledge is that you can't cache anything. And of course, since there are big warnings if you serve the images on your website from a different URL than the main page, chances are you're going to serve your images over HTTPS as well, which is kind of ruining the whole let's try to cache thing so that the website can be downloaded faster. That's not true. The majority of browsers will happily cache content served over HTTPS if you provide a caching instruction of public. If you say the content is public, it will be cached. Use it for all your images and your CSS. People that are on very slow connection will thank you. Right. Oh, I forgot I had that subtitle. But you have to say that it's not completely untrue. So, learn cache policies, because this is kind of the Microsoft .NET way of calling .NET caching instructions. That lets you query the cache, and more importantly, because that's something that very few people know. When you are using .NET, I assume everybody's using .NET. Yeah, who's not using .NET at all? Oh, there is some hope. If you're using .NET and the web client class or the HTTP web request class, etc., all those classes that you can create to access web content, you are using the browser cache. You are using Internet Explorer's browser cache called WinInet, because of course the cache is not actually an Internet Explorer component, it's a Windows component, wininet.dll, that handles the caching, which means that your .NET application's behavior will change when users update Internet Explorer. Is that cool? So, when you want to test your application that uses caching and it happens to use .NET, you have to test it across all the versions of Internet Explorer that you're deploying to. And you thought that .NET was solving things. Right, so which means basically that your cache is kind of a little bit broken anyway for all versions up to Internet Explorer 10. So you want to check that. But it does mean that if you try to retrieve code using .NET to get, let's say, the latest jQuery file, it will hit the same cache as Internet Explorer. Which means that when your boss went onto Facebook, you now have all those scripts you can download from your application, and you will hit the cache. But you need to test across platforms, which means you probably need multiple VMs, or what is it that they recommend for Internet Explorer testing? I mean, except for suicide, that is. I can't remember. I think there's still VMs that you can download. Huh? You can automate the testing with Selenium, yes, for Internet Explorer. For your Windows application, you can do the same thing. That's true. You still need multiple machines with multiple versions of Internet Explorer. There is a compatibility mode. I wouldn't ever test anything using all this rubbish, because I don't trust Internet Explorer compatibility mode to reproduce all the bugs that exist at the caching level. Actually, I think the compat mode doesn't apply to caching. Interesting question, I'm not sure, but I think the compat mode is completely independent from the caching. So, for the scope of this talk, you probably need to have different VMs with different versions of Internet Explorer if you want to test that. Now, all this is to explain to you how great caching is and how you can leverage the infrastructure that exists today to start caching your business data in infrastructure that's already been deployed. Stop building your own cache. Just in general, stop building your own caching systems, because it's freaking complicated to do it right. If you want to build an HTTP cache properly, this is the diagram you would have to follow. This is a simplified version, by the way. It's not including everything. Don't do it, you know. Help yourself. Help yourself and don't build it. In general, that's a good software practice. Don't build it. That's a good start. But if you really want to build it, then that's cool. I got an open raster caching module that you can come and work on. Here's a couple of links that are useful. The first one is on performance tuning on HTTPS. That presentation is already online, so just search for Serial Seb HTTP 101. You will probably find it quite easily. So the links are available there. I would put it on my blog, but no one reads my blog, so because I never write anything on it, I suppose. Performance tuning for HTTPS contains plenty of information about caching. That's very interesting. Secondly, if you're an HTTP geek, or if you want to know if I talked rubbish, this is the second line is the HTTP specification page, where you can go and read HTTP 1.1 bis. a project that started a couple of years ago to clarify the existing version of HTTP and make it readable by normal people. I'll leave it as an exercise for you to decide if that was successful or not. Line underneath it, personal project, there are no tests, it's horrible WinForms code, but it's just to show you stuff. You can download the HTTP Workbench. It's a tool that is letting you craft HTTP requests using .NET classes and mess with the configuration, and it hosts a web server as well, which provides caching so that you can test what is going to happen when you do your request in a self-contained environment. It's all running within WinForms environment with an open raster server, so it's very cool, and there's very little code. That's very interesting. Use that. Open raster, if someone wants to take ownership of that project, please come along. It was the premier biggest alternative web framework on .NET for a while, so we still have a very cool logo, which I personally like very much. But there you go. I'm Sebastien. Those are my contact details. Don't try to contact me by email. I never reply, and if I don't reply by Twitter, just keep on trying. I'm just absolutely horrible at keeping track of who I'm supposed to talk to. I think I've got 1 minute left, so I'm going to thank you, and I'm going to suggest that if there's any questions, come and chat with me while other people can go to lunch. Thank you.